Hello, and welcome back to College Algebra, MAT 150. In this lecture, we will be discussing rational functions and asymptotes. So what is a rational function? Well, we already have underlined the word ratio, and when we hear the word ratio, what do we think? Well, we think of fractions. So what are rational functions? They're just fractional functions where what's in the numerator and denominators are both polynomials. We have only one little caveat there, and that's the degree of the denominator has to be at least 1 to be a rational function. Otherwise, we wouldn't have an x, basically wouldn't have a variable in the denominator, and it could just be a number, and hence it will actually just simplify to being a polynomial. So why do we care about rational functions? Well, they have a lot of unique things in them. Amongst those two things are asymptotes and wholes. Okay, and asymptotes, so we're going to start by talking about asymptotes. And asymptotes are ways to talk about in behavior. Okay, so they're an equation that determines how the function behaves at extremities. And so just like with polynomials, the arrows that we drew, those were the in behavior. Asymptotes are an equation that tell us, hey, this is how this function will sort of end up at in the end. Okay, and they're the two most common type of asymptotes we're going to talk about. There's many more, but they're the most common ones that pop up are vertical asymptotes and horizontal asymptotes. And again, to be clear, asymptotes are a particular equation. Okay, they help us determine in behavior, even though they themselves are not actually the in behavior. Okay, they are equations of line where the graph tends towards. So vertical asymptotes are vertical, and the equation that represents a vertical asymptote was unsurprisingly the equation of a vertical line, so x being a number. And horizontal asymptotes are given by horizontal lines, where basically horizontal lines where our graph tends towards, and they're given by y equals a number, which are both vertical lines and this is a vertical example of a vertical line and a horizontal line. So what can we determine? So let's look at something we know. Let's talk about the graph of y equals 1 over x. So earlier we had talked about this, but now we're going to go in a little bit more depth. So as it turns out, the graph of 1 over x has a vertical asymptote right here and a horizontal asymptote right here. And 1 over x has this base point 1, 1, and unsurprisingly, as we get closer and closer to these, it sort of goes towards it. It gets really, really close. So we say that this is where the in behavior sort of happens, and this is how it happens is along these asymptotes. Further, we have the other part of the graph, which is on this side, and it's at this point we note how many arrows are pointing. So normally with polynomials, we would only ever have 2 arrows pointing away. Here we have 1, 2, 3, 4. Again, so what do asymptotes tell us? They help us. They help tell us the in behavior of the graph. Okay, they're where the graph tends towards. All right. So first off, we have one that's vertical and one that's horizontal. Again, the one that's vertical is given by x equals a number, and it goes up and down the x equals 0 number. And this is a horizontal asymptote. And our vertical asymptote. So it goes up and down, and it's vertical, so it is our vertical asymptote. Our horizontal asymptote is given by the horizontal line. Again, that's y equals a number, and the number it equals is 0. All right. So these are our asymptotes, and again, we have this equation. However, we knew where these asymptotes were, and we then derived the asymptotes from the graph. Usually, it will be the other way around. From the equation, we're going to find the asymptotes, and then we're going to put them on the graph to help us determine what the graph will look like. So if you're given a rational function, we can find vertical asymptotes simply by solving for when the denominator equals 0. So vertical asymptotes, and this is a generic way, there's a couple of caveats here, but if we set the denominator, what's the denominator? It's x. So if you set x equal to 0, well, it's already solved. You can't really isolate x anymore. Then that's your vertical asymptote. You could have multiple factors, and you could set all the factors equal to 0. If the factor of the denominator is also in the numerator, then ignore this for now. This is something we're going to address soon. So what we're saying is, if you're trying to determine a vertical asymptote from an equation or from a function, what you do is you factor the top and bottom completely, and then only look at the unique factors from the top or unique factors from the bottom. So if they're also in the top, don't worry about them. Okay, and those values where the denominator becomes 0. Where x equals a make the denominator 0 are the vertical asymptotes. That concludes this lecture.